Hello. In this video, we're going to be looking at several points and determining whether they lie on a circle with specific criteria. So in this example, we have a circle centered at 1, 2, 1, 2 being right there, perhaps a little higher than that, and it has a radius of 10. Now, my circle can go out 10 units. You, when you draw this, may want to tick mark differently than this, perhaps by 2 in each direction as a scale factor instead of by 1 in each direction. But from here, that means I can go 10 to the right, so that puts me at 11, 2. I can go 10 up, which puts me at 1, 12. I can go 10 to the left, which puts me at negative 9, 2, and then 10 down, so 1, negative 8. And there's my circle. Now, the directions ask us to determine whether the following points are on the circle, and the first one we have to talk about is 1, 12. Well, we know 1, 12 is on the circle because it's right there. We already listed it. So we know the answer to the first question is going to be, yes, it's on the circle. But what happens when one of the points that we're being asked about is not one of the 4 easily found points? So we have to do a bit of math to figure that out. Now we know that the distance from the center to each point should be 10 units. And we also know that we can easily find the distance between any 2 points. And that's using the distance formula that I'm now writing at the bottom of the screen here, where we subtract our x's and square, then we subtract our y's and square, add them up, and then square root. Remember, this is just a version of the Pythagorean theorem. So to calculate this for number 1, well, we want to just determine what's the distance between 1, 12 and 1, 2. So the distance between them is, and again, our big square root, we subtract our x's, 1 minus 1, and squared, plus we subtract our y's, 12 minus 2, squared. So when we start to simplify, 1 minus 1 is 0, 12 minus 2 is 10, 0 squared is 0, 10 squared is 100, so we get the square root of 100 when we add, which results in 10. And you can see that our distance between these 2 points is 10, and that's why our answer is yes. Let's do the same idea for the next 2. In number 2, we're looking at the point 7, 10, which sits right here on my graph. Now, that looks plausible to be on the circle. Let's test. So we'll just look at the distance between these 2. So the distance, and we'll subtract our x's, so 7 minus 1 squared, plus, and then we'll do our y's, 10 minus 2 squared. And so we begin to simplify. 7 minus 1 is 6 squared, plus, and then 10 minus 2 is 8 squared. 6 squared is 36. 8 squared is 64. When we add those together, we get 100. And sure enough, the square root of 100 is still 10. So is 7, 10 on the circle? The answer here, of course, now is yes. All right, we have one more to try here. It's negative 7, negative 6. Negative 7, negative 6 puts me right here. There we go. Again, plausible for it to be on the circle. So let's see. We check our distance. We subtract our x's, 1 minus negative 7 squared, plus 2 minus negative 6 when we subtract our y's. And we begin to simplify. So 1 minus negative 7 is 8, still being squared. 2 minus negative 6, also 8. So 8 squared is 64. 8 squared again, 64. When we add these together, we get 128, which is not the same as 10. So, is this on the circle? The answer here then is no, not on the circle. And we have the work to back it up. Why it's not? Because the distance between the center and that point is not equal to 10. Okay, so to determine if a point is on the circle, we're basically using the distance formula, which is just a version of the Pythagorean theorem. For now, we're done.